Okay, so as we saw with the square root function, there was a relationship between the square root and the square function. They kind of look like they were tilted versions of each other in a certain sense. We're going to have that same sort of thing with the cubed root function and the cube function. We're going to recall the definition of the cubed root. So if you have y equals the cubed root of x, that means exactly that y cubed is equal to x. So start thinking about what can you plug in for this y and what kind of thing do you get out over here. So if I plug a positive number in, positive times positive times positive gives us a positive, that's fine. If I take 0 times 0 times 0, we get 0, that's also fine. And if I take a negative number multiplied by itself 3 times, so a negative times a negative times a negative, the end result is also negative, which means that there is no restriction on the domain. And any number, y, by taking x over here large enough, can be produced by taking the cubed root of it. So the range is also going to be r. We'll give a quick sketch of this. So the cubed root of 0 is going to be 0. Cubed root of positive 1 is 1. Cubed root of negative 1 is negative 1. And then the next nice cube root that we have is going to be the cube root of 8. So if you think about that, that's going to be the number 2. And so we would have on this line over here, this horizontal y equals 2 line, above x equals 8, we would have a dot. So somewhere out in this vicinity. Likewise, if we did negative 8, well, you'd end up getting negative 2 as the output. So that's going to give us a functions graph that looks like this. And so the x-intercept is 0, y-intercept is also 0. The symmetry, well, we have that right up here. If I take the cubed root of negative 8, that gives us negative 2. Negative 2 is really the same thing as negative times 2. That seems silly at first, but you'll see where I'm going with it. Now, this 2 is the same thing as the cubed root of 8. So notice that we start with a negative inside the function, do some algebra, and end up with a negative outside the function, which means the symmetry is odd. And you can see it graphically here. If you put down a pin and you spun the paper 180 degrees around the pin, this picture should look exactly the same. Where's this thing decreasing? Well, since we're interpreting everything moving left to right, it's actually never decreasing. And as you move left to right, you're coming from, say, down here, up, and you're just going to keep going and going and going. So you're increasing everywhere on the domain. Since there's no change from increasing to decreasing, there's no local mins or maxes anywhere, which means that there's also no absolutes. If you were to take this and you were to say, rotate it, and then you were to take that again and flip it over, it would look exactly like the cube functions graph. And there's a reason for that relationship, which we'll explore later this semester. Next function we need is the reciprocal function, which just takes a number and does 1 over that number. So we'll start by figuring out the domain. We have a division, means that x cannot equal 0. So over here you have negative infinity to 0, 0 to infinity. So everywhere else above any other x, we can have a point on that graph. Let's just start picking it out. So if we plug in 1, we get 1 over 1, that's fine. If we take 2, we get 1 over 2. If we take 3, we get 1 over 3, and so on. So this thing keeps getting closer and closer to the x-axis, the larger your x value becomes. And as you move closer to 0, let's see what happens when we take 1 over 1/2. Well, to solve this, because we have a number over a fraction, we have to take the reciprocal. So that's 1 times 2 over 1, which gives us 2. So as you get closer to the y-axis, your function's graph just blows up. So the closer you get to 0 with your x value, the larger the output is. And let's review a property of fractions. If I was to do 1 over negative x, well, this negative, it doesn't have to go in the denominator. It could go in the numerator, or it can just come right out front of the fraction. And so if I was to do the reciprocal of negative x, we get negative of the reciprocal of x, which tells us that the symmetry is odd. And using odd symmetry, we can get the other half of the graph for free. Now we need to figure out the x-intercept. Well, looking at the range will tell us the x-intercept. Ask yourself, is there a way to solve this equation? Well, a fraction is equal to 0 when the numerator is 0, and we can't plug 0 into the denominator, which means this thing never happens. We don't have any value x to make this true. Which means the range is going to be negative infinity to 0, union 0 to infinity. Since 0 is outside the range, the x-intercept, there is none. And since 0 is outside of the domain, our graph never actually touches the y-axis, and so there is no y-intercept. Now, again, decreasing and increasing is interpreted from left to right. So as you move to the left with your x values, well, this keeps getting more and more and more negative. So that's decreasing. Then we jump up here and we just keep decreasing. Our values keep getting smaller and smaller and smaller. So we are decreasing everywhere on the domain, which means we are increasing absolutely nowhere. Since there is no change between decreasing and increasing, we have no local extreme values, which means we have no absolute extreme values. Which brings us to our next function, the absolute value function. And remember that this function tells us how far away from 0 that number is. So we can begin by figuring out how far away from 0 is the number 0, and it is 0 units away. So that tells us 0, 0 is a point on the graph. 1 is 1 unit away. Negative 1 is also 1 unit away. 2 is 2 units away. Negative 2 is 2 units away. And you can kind of start to fill this in here, and that's the classic V-shape absolute value function. Right, and the domain, it's everything. We can figure out how far away a number is from 0, no restriction on the number. And our graph is completely above the x-axis. There's nothing down here. And so we go from 0 to infinity, including 0, because the absolute value of 0 is 0. The x-intercept is 0, y-intercept is 0. Symmetry, if we took this and folded it right over the y-axis, this line should land right on top of that line, which means that this is an even function. Where is this thing decreasing? As we move from left to right, all the way from negative infinity to 0, we keep going down. And from 0 onwards, we're increasing. Our local maximum, there is none. Our local minimum, that's going to be 0, right? Right down here, this is the smallest value. Since we have no local max, there is no absolute. And right here, 0 is the smallest output that this function puts out anywhere. So that's going to be 0. Another one that we need, they're called constant functions. So y equals b, and b is just any real number. Essentially, you're plugging in a number. We'll rewrite it this way. So f of x equals b. So if I plug in the number 0, this function just tells me b. If I plug in the number -2, this function just tells me b. If we plug in the number pi to the 3.729, the output's still going to be b. Regardless of whatever you put into it, this function always tells you b. There's no change whatsoever. It is constant. So let's just arbitrarily pick somewhere to draw this line. And the height is always going to be the same. We'll just call this y equals b. From this picture, it looks like y equals 2.5, but we had to draw something. Domain, you can plug any number in. So we get r. The range, this function just says b every single time you plug a number in. So the range is just going to be the set b. X-intercept, well, it's never going to happen unless it's 0. So it depends. None if b is not equal to 0, and I guess r if b is 0. Our y-intercept, it's at b. Symmetry, this is definitely evenly symmetric. If you fold this over, that should fold right on top of that. Where is it decreasing? Nowhere. Where is it increasing? Also nowhere. Local max, absolutely nothing is changing. So there is no max, there is no min. It's really straightforward, kind of boring.